Hi everybody, welcome back. Today we're going to talk about how to change the base of a logarithm. So we're going to go through two different ways today on how we can change the base of a log. And so what I want to do is I want you to take a look at question 1a, and we're going to go through and we're going to follow the instruction to evaluate. We would expect you to be able to just simply say 2 to what exponent gives you 32, 5, and you're done. You take a look at problem B, and B would be a more difficult one, and it's one that we've encountered before, but we should be able to estimate that to be approximately 2 point something. What I want to do is I want to walk through how we can evaluate what log 18 from base 3 is. So one of the things that we could do is we have a log, and we can set it equal to some unknown value. So I'll just go with a default of x. By setting that log equal to a number, it gives me the ability to change that log into an exponential form. And once I've done that, I've now created an exponential equation that we've got in our background to be able to solve. And so I see my variables in the exponent, I got to get it out, which means I need a power equal to a power base the same. I can't change 18 into a power base 3 very easily. And so I take the log of both sides. That allows me to bring that exponent out in front, and then I can divide out my log 3 and solve for x. And so for me to evaluate what log 18 from base 3 is, I can simply take log 18 divided by log 3. So have your calculator handy and go ahead and punch that into your calculators now that you've changed those into a base 10. I want to come across then a way that we can calculate every single log. For some of us, your calculator actually enables you to enter in log 18 from base 3. For others, your calculator is defaulted that when you push your log button, it only allows logs base 10. I want to go through and make sure that we could evaluate any possible log given. So what we're going to do is we're going to deal with a little bit of a proof. And we're going to take that for us to be able to go through and evaluate log 18 from base 3, really all we do is we take the log of the result and we divide it by the log of the base. And so to prove that, what we're going to do is we're going to create a very generic log. Log b from base a. And now we're going to go through that same process in generic terms to see what we have. So we could go through and set that equal to x. Now that enables us to change that into exponential form. You can take the log of both sides. That allows you to bring that exponent out in front. And now to isolate our x means that I divide out my log a. So notice what we have in blue is an algebraic proof for what we have in red. Now, to make it even more generic, I want you to just take a peek at the way that when we decided that we had a power equal to another value, and we couldn't write them as powers of the same base easily, so we took the log of both sides. I just generically wrote down logs base 10. The only reason I did that was because my calculator has all logs programmed. But I could have taken that from a log of any base. And so I just generically put in a log base c. Well, if I follow that through then I actually come up with a very important property. That not only for me to evaluate log b from base a means log b divided by log a, but it also means that I'm able to take a log that is base a and rewrite it as logs base c. So this gives us a way to evaluate every log using any calculator, but also it gives us a way to change the base. So now that we take a look at C, C is just a process for us to make sure that we are good with how we evaluate. For me to calculate what log 25 from base 4 is, I can take log 25 and divide it by log 4. So you can go ahead and use on your calculator to get a little confirmation. We should know that we should get 2 point something. 4 to what exponent gives me 25? I'm in between 2 and 3. Now, you take a look at D, and D would have been a problem from before where we would have said, okay, 4 to what exponent gives me 32? And maybe in our heads, we were thinking about the fact that 4 is 2 squared, and 32 is 2 to the 5th. And so really I need to get rid of the squared on the 2 and put an exponent 5 on, 5 halves. That was a log that for some of us was quite difficult to do in one step. I want to show an alternate solution to that now that we understand change of base. That if I recognize that 32 and 4 are both powers base 2, then maybe what I do is I break it apart into powers base 2. So notice I have the log of my result divided by log of the base. I just chose each of those bases to be base 2. Because you'll notice on the top of the blue fraction, I'm now able to evaluate that quite easily. 2 to what exponent gives me 32? And 2 to what exponent gives me 4? And we come in on the same line. So this gives you an alternate way to be able to evaluate logs. Having many options is good for us. So let's take a look at E, and really what I'm going to focus in on is the blue method. If I have 27 and 1/9, and I notice that those are both powers base 3, then I can rewrite that log as the log of the result divided by log of the base. And since they're both powers base 3, I'm going to change them into logs base 3. Because on the top, I can pretty easily say 3 to what exponent gives me 1/9? That would be a negative 2. And on the bottom, 3 to what exponent gives me 27? 3. Again, it's another way for us to be able to evaluate logs. And it's really nice, especially if we were struggling with those logs earlier. Now, the rub might become a little bit that you guys might be saying, why didn't you just show us this earlier? But I want to be very clear here. Had we gone through and shown you this earlier, too many of you would become button pushers. You would simply trust your calculator. And for us to have a true understanding of what we're dealing with, we need to be able to evaluate relatively simple logs without a calculator. So hopefully that gives us multiple ways to go through, and that'll help us as we go. I want to kind of change focus a little bit now. So when you take a look at that red problem that I've thrown on the screen, there is our prove. And what we're going to do is we're going to go through and we're going to prove that relationship. That the log of b from base t is equal to 1 over log t from base b. Now, what I would like everyone to do is to pause the button or the video and try this one on your own. Try to take left side and right side and break them apart to try to manipulate each one to see if you can make it look like the opposite side. Okay, pause it now and give it a shot. Okay, we're back. Now, I'm going to go through this a couple different ways. And one of the ways I want to go through it is not going to be a way that I would ask you guys to deal with it. This blue method is something that I want to make sure that we are good with in terms of a process. So, maybe I take a look at that left side and the right side, and I look at the left side, and I'm going to try to manipulate that left side. So I've got log b from base t. Well, I know that I can break apart any log into log of the result divided by log of the base. But I don't know if that's going to help me so much right now. I have to somehow try to take log b divided by log t and change it into 1 over log t from base b. Well, I can put that 1 over relationship in there. as long as I know that if I divide, I have to divide by the reciprocal. Now, for anybody who's kind of looking at that a little bit and they're unsure how that came about, if I was to ever take a fraction, like for instance, 2/3, and I wanted to write that as a 1/, relationship, then I need to divide that by its reciprocal. Because you know that to divide fractions means you flip and multiply. And notice, both sides of that yellow equation are equal to 2/3. So for me to be able to take that, I can rewrite that in the blue form. And just as if I can take apart a log, I can also bring it back together. And so on the denominator of that big fraction line, if I have log t divided by log b, then I can rewrite that as log t from base b. So hopefully not too painful, but one very quick approach to get there. Now, if I were to go through and prove this, there's a much more direct route. So what I could do is I could simply take that left side again, and when I broke it apart into log b divided by log t, I'm going to argue I really had the blinders on. I broke it apart into logs base 10. But the problem is, look at the right side of your red statement. I don't have a log base 10 anywhere. I have log b's. So as soon as I broke that apart, I'm going to choose what base I want to use. And I'm going to change the base into base b's. That allows me to evaluate on top, because log b from base b is 1, and on the bottom, and I come in with a more direct proof. Now, why is this proof meaningful? Because if you take a look at that red statement, if I have any log, I can interchange my base and my result if I move my log across its fraction line. So log b from base t is equal to 1/, log, and now I see my base and my result flipped, t from base b. Let's take a look at this in practice. So, lastly, this would be a problem, and it would be a very generic proof for us. The problem says, show, that means the exact same thing as prove. And so, the only way that I can prove is to take left side and right side, break them apart, and show that they have the same value. So, I take a look on the left side and the right side of that statement, and I notice that my left side has got more stuff on it. And since it's got more stuff, I'm going to play with that side because I likely have more options. So the first thing I can look at is my first fraction is 1/, log 5 from base 3. My second fraction is 2/, log 5 from base 4. Well, it would have been really nice if both of those logs would have had the same base, because then I could have used my properties of logs to manipulate it. They're not the same base. However, because I noticed that both of them have the same result, then I have a method for changing the result and making it the base. So, if I was to move that log across its fraction line, then I can interchange my base and my result. That means on my left side, I could rewrite that as log 3 from base 5. Now I can do the same thing with that second log. I have a coefficient of 2, and if I move that log across the fraction line, then I interchange the base and the result. I really like having those two logs because now I have logs base 5. My only issue is getting rid of that 2 from out in front. And I know to get rid of the 2 out in front, I can move that back up to the inside, so I have 4 squared, which is 16. And now I have a single log plus another log. And so since I have addition between two logs, then I have multiplication on the inside. And the only thing left is now to make that look like the right side. And so now I can take that log and I can move it across its fraction line to interchange the base and the result. There we go. Left side equals right side. I know my proof is good. So, two properties that I want you to kind of work through and get some practice with to make sure that we're good in terms of changing the base of logs. Good luck.